Today, we want to talk about making some nice graphs of sinusoidal functions, specifically y equals sine x and y equals cosine x. Once we can make a nice base graph, figure out the basic graph, we can name some parts, some common features that we have, and then we can start messing with these functions. Start moving them around horizontally and vertically, start stretching them out horizontally or stretching them out vertically. So let's first get nice base graphs going on and talk about the different parts. So I've made up a bunch of dots here. It's just a zigzag with a middle, a top, a middle, a bottom, a middle, a top, a middle, a bottom, a middle, and it just keeps going forever. Let's name those parts. Up at the top, I'm going to talk about the top. Up here, we'll have the top. I'm going to put it in quotes because these aren't technical terms. These are just where we're going to refer to things. We have this graph going up and down, this wave form. And we want to make sure we can draw a nice wave. So we're going to talk about the top. We're going to talk about the bottom. And in the middle, we're going to have the middle. But there's two different versions of the middle. There's the middle going up and there's a middle going down. So I've only drawn these dots here, so it's like very low resolution, but we see here's the middle going up. Then we're at the middle going down to the bottom. Middle going up to the top, middle going down to the bottom. So in the middle, we'll have two. There's a middle going up and a middle going down. And then generically, we could just refer to that line as the middle. So this is how I name the parts. I have the middle. And relative to the graph, there's either a point that's a middle going up or a middle going down. I've got stuff at the top. And I've got a line at the bottom. And then I've got the middle going up and the middle going down here in the middle. I just realized I use orange and blue on the middle, so I use Mets colors on the middle. Ugh. If you're a fan of the Mets, I'm sorry that you're a fan of the Mets. I mean, really, who's a fan of the Mets on the West Coast? No one's a fan of the Mets, right? That's good because I would have to kick you out of the class if you're on the West Coast and like, oh, let's go Mets. No. You know why the colors of the Mets are orange and blue? Because the Giants left and the Dodgers left, leaving no National League team in New York. And New York, being the center of the universe, had to have a National League team. So they made the Mets and they just used the two colors. They're a recycled team at best. If you're a Yankees fan, I'd have to have you expelled from the school because the Yankees, no. Is anybody here a Yankees fan? I have to tell you that I would have you expelled for being a Yankees fan before I ask if anybody's a Yankees fan. So all the Yankees fans can say, no, I will just leave. By the way, you have to leave, Yankees. I'm just kidding. It just doesn't matter. It's just not a big deal. I do have to point out the Yankees and the Red Sox only have a rivalry because the actual rivalry left town and New York felt left out. The only real baseball rivalry between the Giants and the Dodgers left New York, and that's why the Yankees had to come up with a new rival. Forget all that Babe Ruth nonsense. They just had to invent one. I'm just kidding. I don't know why Boston and New York would argue over baseball. But seriously, it's just the Yankees. Oops, the bottom is green. So these are the points that I'm going to refer to. I'm going to talk about the top, the middle, and the bottom. And we're going to refer to the middle going up and the middle going down. If the next point, we just go middle, top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, forever. No matter where we start. If we start at the top, top, middle, bottom, middle, top, middle, bottom, middle. If we start at the bottom, bottom, middle, top, middle, bottom, middle, top. So it's just repeating that pattern. If the next thing is the top, it's the middle going up. So at this point, it's a middle and it's going up because the next one is the top. Here's another middle going up because the next one's the top. Then the other ones are the middle going down because the next one's the bottom. I didn't draw another top after this. I ended off at the middle, but this point would be a middle going up because the next one would be at the top. Any questions? This is how I refer to things. If you want to draw a nice sinusoidal graph, you're going to want to be able to cut the distance from the middle to the top in half. So notice that I left 2 squares from the middle to the top, so I could easily find a half. So I can easily find my halfway point. So I want to be able to easily find the halfway point. So wherever I drew the middle, I hit 1 square, so I could easily find halfway, and then the next square up was the top. So I divided in half vertically. Horizontally, I put the points 3 spaces apart. I want to be able to divide it in thirds. So each of these points is 3 spaces apart. So here's 1. Horizontally, I want thirds. "30, 60, 90, half, and then 1. Vertically, it's a half and then a 1. Horizontally, 0, 30, 60, 90. I want thirds horizontally. Halves vertically. What we want to be able to do is connect these dots into a nice sinusoidal graph. Remember, horizontally, each space is 30 degrees. I smashed this a lot closer together than I did last week when I drew it out really far, but I wanted to get more cycles going through. You get halfway when you're 1 square off of the middle. We hit halfway 1 square off of the middle. So when I'm over 1 square, that's when we hit halfway. Then 2 squares at the top. When we're 1 square on either side of the middle, We're at halfway. These are the purple dots. We're halfway up or halfway down, 1/3 of the way to the next dot. So if we want to draw a nice one, and we want to get the proper flow going up and down, and we don't just want to draw a jagged line, a pointy one. You don't want to do that because it'll be sharp at the corners and you'll cut yourself. It's a safety issue. Halfway up, 1/3 of the way from the middle. That's why we're using 3 spaces, so we can evenly space. So here's a middle. We go 1 square on either side, and that's halfway up. 1 square on the other side, halfway down. And then to get to the bottom, it's like 2 squares horizontally to cover the rest of the half, the other half. Half at 1/3 of the way between, I phrase it saying 1/3 on either side of the middle. The best way to remember this is that sine of 0 is 0, sine of 30 is a half. The half happens at 30 degrees. Once we have our halfway points, you draw your function almost linear connecting those. In fact, you draw at such a low resolution, you just connect those 3 points with a line. The 1/3 at the halfway and the middles all connect with lines. So I'm just going to connect all these with lines. That's how I'm going to draw my middles going up. Here's another middle going up. Here's another middle going up. And the middle's going down. I have to change the angle of my hand, so that was a little sloppy. If your aim is a little bit off, make bigger targets and sketchier lines. But there I am connecting all the halfway marks with just lines. Middle going up, middle going down. Connect those with lines. Now, all we have to do is draw little peaks and valleys, nice and evenly spaced. So then the last step is to draw nice little peaks and valleys to connect the lines. We also run out of colors. So now we'll connect with peaks and valleys. You want to make sure you draw it flat when you get to the top. And it should be as symmetric as you can make it. So connect the lines to the top with little peaks and valleys to connect the bottom. And just make them as symmetric as you can. Imagine drawing, just connecting them with lines and then just rounding it out a little bit. So I'm imagining just connecting with lines, but then rounding it out a little bit. Aye, aye. And then we will have really nice sinusoidal graphs in glorious Technicolor. So halfway marks going up and down. So the middle, halfway, and a 1, negative a half, negative 1. And then remember, we hit the top at 90. So think 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 230, 360. So 3 dots horizontally, 2 dots up and down. When we're cutting through the middle, we want to be cutting through one particular kind of slope, and then we want a flatter slope to get the peaks and the valleys, is what we're going for. We want to make sure that we're not just making jagged lines up and down. We want to know how much to widen those out. So instead of just a vertical up and down, how much do we want it to widen out? How much should we drag out the sides? Any questions? How's everybody okay? All right. This raises the question, are you going to be graded on how cleanly you can draw a sinusoidal graph? Not really. But some people are going to be annoyed if they can't get the right proportions. This is how to get the right proportions. This is also how it's going to help us remember our values. It's going to remember our trig values. Notice that this one, I chose to start off at the middle, going up. So what I've started here is to draw sine. Cosine starts different. Cosine starts at the top and heads down. So cosine will start off up here at the top. So that's why I didn't label the horizontal axis with any 0, 30, 60, or 90, because the 0 happens differently for sines and cosine. So here's what we want to, here's the other thing. When we have the graph, notice that the graph starts off at the middle going up, then to the top, then the middle, then the bottom, then the middle. That is one period or one cycle of the graph. Since there's no horizontal distance, from middle going up to the next middle going up is one cycle. From the top to the top is one cycle. From the top to the top is one cycle. From the middle going down to the next middle going down, that's one cycle. From the bottom to the bottom is one cycle. From any point to the next similar point, that's one cycle. So when I refer to one cycle or one period, we're talking about a point to the next similar point. So that would be the middle going up to middle going up. Or from the top to the top. Or from the middle going down to the middle going down. Or from the bottom to the bottom. That's going to be one cycle. This is going to represent going around the circle one time. So our default is going to be 360 degrees. So our default period for sine and cosine is 360 degrees. We're going to remember this because one cycle or one period is going around the circle one time. That's how we're going to remember that. Another feature that we want to point out is how far it is from the middle to the top and from the middle to the bottom. We're going to refer to that distance as the amplitude. So the cycle or a period is a horizontal distance. The amplitude is going to be a vertical distance. The amplitude is going to be the distance from the middle to the top or the middle to the bottom. They will always be the same for sinusoidal graphs. And so it doesn't matter which one we measure. That's going to be the amplitude. Amplitude is a vertical thing. Period is a horizontal thing. The amplitude for y equals sine x and y equals cosine x is 1. That's the distance from the middle to the top and the middle to the bottom. So the middle is at 0, the top is 1, the bottom is -1. That's because the highest value of sine x and cosine x is 1, and the lowest value of sine x and cosine x is -1. How's everybody okay? Just naming parts. Period is a horizontal thing. Default is 360 for sine x and cosine x. Amplitude is a vertical thing. The default value is 1 for sine x and cosine x. We're going to have to come up with ways of making amplitudes other than 1. We're going to have to come up with a way of using a bigger circle than just a unit circle. We're going to have to stretch the amplitude and stretch or squish our period. But our default values are 360 for the period and 1 for the amplitude. Amplitude goes in both directions, up and down. So 1 and -1. Any questions? How's everybody okay? Remember the cycle of points. Middle, top, middle, bottom. Middle, top, middle, bottom. Middle, top, middle, bottom. Middle, top, middle, bottom. Let's talk about default starting points. It's really weird to say starting points because the graph goes forever in both directions. But the way that we're going to think about it is, what does one cycle look like? So think about the way we're going to think about it is we're going to say cosine starts at the top. To make sure we represent the fact that we know that these graphs go on forever in both directions, we're going to put starts in quotes. And we're going to say it, kind of derisively. Cosine starts at the top. You don't actually have to do the finger quotes, but you do have to be really snarky when you say starts. That way it demonstrates to your audience that you understand that the function goes on forever in both directions. And that you're kind of using some soft, weirdo language to say cosine starts at the top. Starts at the top. Just kind of like be really snarky about it. It's especially funny if you be this snarky when you're talking to people that aren't in this class who weren't trained to say these things so snarkily. Is snarkily a word? To say something in a snarky fashion? Snarkily. It's a word now because I just said it. Cosine x starts at the top. How is this connected to the stuff we did before when we were learning our values? This makes sense because cosine of 0 is equal to 1. And that's where we start our circle. Oh, for you, it's over here. 0. And then we start off with cosine of 0 is equal to 1. And then it drops down. The x coordinate drops down to 0 when we get to 90 degrees. So this makes sense because cosine of 0 is equal to 1. From the top, there's only one way to go, and that's down. And so the next point, cosine of 90 is equal to 0. That's when we hit the middle. And it's also the middle headed down. This makes sense. When we keep going, the x coordinate keeps going negative to -1. So cosine of 180 is equal to -1, and that's at the bottom. Then if we keep going from 180 back around the circle to 270, our x coordinate went back to 0. And that'll be at the middle going up. When we get back to 360, we have completed one cycle, one trip all the way around the circle. And so we are back at the top. This is why we like cosine better. It's a better story. It starts off at the top. There's this fall down to the bottom. And then we finish the story by crawling back to the top. Back on top. It's a much better journey, right? Typical kind of sports movie version. Champions. Oh no, stuff has happened. Now we lose. But then we start believing in ourselves again. And Dwayne "The Rock" Johnson starts training us. And at the end of the movie, we win the big game at the end and we're back on top. So this all comes from the fact that we're thinking about cosine x as starting off at the top. This is going to help us remember the values, or remembering our values is going to help us remember this. We're going to use this to help us remember that cosine of 0 is equal to 1, and that cosine of 90 is equal to 0. We're going to remember that 90 is in the middle, and that 30 degrees off the middle, that's where we hit a half. So remember, 30 degrees off the middle, either side, is where we hit 1/2. Both the middle going up and the middle going down, 30 degrees off the middle is where we hit 1/2. So this is going to help us remember our values, because at 90, we're at the middle for cosine. 30 degrees above and below is 60 and 120. Going to help us remember stuff. We're just looking at all the structure that we can use to help us remember our values, to help us remember our graphs, to help us remember our values, to help us remember our graphs. Notice that I wrote cosine of 120 is -1/2, because 120 is in the second quadrant and cosine is negative in the second quadrant. We've got to remember all the things all the time. Values, quadrants, graphs. Graphs, quadrants, and values. Our other middle is 270. 30 degrees off of 270 is 240 and 300. So 270, the other middle, minus 30 is 240, and 270 plus 30 is 300. 30 degrees off the middle is where we're halfway up and down, 1/3 of the way. So now we can say that cosine of 240 is -1/2, and cosine of 300 is +1/2. Cosine is negative in the third quadrant. Where all this reasoning started was thinking about cosine starting off at the top. Cosine starts at the top. We're going to follow this a similar line of thinking, not the same, a similar line of thinking for sine. And we're going to remember that sine starts at the middle going up. So I want to think about y equals sine x. Once again, starts at the middle going up. So I don't have to write middle going up, I just write mid and then an arrow pointing up. So middle going up. Our default middle is 0. Remember, middle is vertical, goes with the amplitude. Middle is 0, amplitude is 1, so 1 and -1. So that's going to help us remember that sine of 0 is equal to 0. Or we're going to remember sine of 0 is equal to 0 because at that point on the unit circle, our y-coordinate is 0. Coordinates help us remember the values, help us remember the coordinates, help us remember the values, help us remember the graph. And then if we start going around the circle, we see our y-coordinate goes up to 1. Makes sense because the sign starts at the middle going up. The graph is helping us remember the value and the direction so that the sine of 90 is equal to 1. And here we are at the top. Sine of 180, the only place to go from the top is to the middle going down. So sine of 180 is back down to 0. This is at the middle going down. Then the sine of 270 is at -1. Here we are at the bottom. And then the sine of 360 is back to 0. Back to the middle, going up, completing one cycle. Took us 360 degrees. So that's how long one default cycle is. This movie is a little bit less hopeful. We start off mediocre. Early on in the movie, we're up at the top. But then there's the fall. And the movie ends with us kind of back where we started from, but on our way back up to the top. So the credits roll with a little bit more hopeful message. Instead of being triumphant, it's more hopeful. So when you're writing movies, you got to decide, are you writing a cosine movie or are you writing a sine movie? Or you could just split it into a couple of movies and go Empire Strikes Back and end at the bottom. You can tell that Empire Strikes Back is only half of a movie because at the end of A New Hope, which was originally just Star Wars, they ended at the top. And then Empire Strikes Back was down at the bottom, right? So that's how you can tell it was only half a movie. It didn't do a full cycle. So it went from top to bottom. So clearly, Return of the Jedi is just Empire Strikes Back Part 2. Or is Empire Strikes Back Return of the Jedi Part 1? I don't know. There aren't 3 movies there, is what I'm saying. It's not a trilogy. They artificially made it into a trilogy. And the reason that this is bad is that Peter Jackson got it in his head, let's make 3 movies out of The Hobbit. It's like, oh, no, dude, no. There's not enough for 3 movies. And then he's like, oh, there will be. Because the studio's like, oh, you know what we need? More money. Make 3 movies. And he's like, oh, there's not material for 3 movies. We'll make material for 3 movies because we want more, what's it called? Money. So I'm surprised all these live action remakes that Disney is doing aren't coming in 2 parts. A live action Pinocchio, part 1. And they just make a whole trilogy out of it. Because they could, well, why sell 1 ticket when they could sell 3 tickets? Why sell 1 Blu-ray when they could sell 3? Why sell 1 digital download when they can sell 3? And then Disney's like, oh, why are people stealing stuff from us? Because you turn 1 movie into 3, you greedy bastards. I'm just kidding. Don't at me. You know what I'm talking about? Have you seen Disney movies? I mean, I'm not saying I'm not going to go see the movies. I'm not saying that I'm not going to go to Disneyland and buy yet another lightsaber. I'm just saying, come on, man. Incidentally, if the next live action movie comes out and it's in parts, I want a cut. What are we talking about? 30 degrees off the middle, that's where we hit halfway. Right? That's the same, right? That's why we divided horizontally into thirds. Because we want 30, 60, 90. We want to take that 90 and go minus 30 plus 30, because 90 was the middle. But now with sine 0 and 180, those are the middles. Because sine starts at the middle, going up. So 30 degrees from the middle both up and down is halfway up and down. The middles for sine are at 0 and 180. So if we take 0 minus 30, zero minus 30 is negative 30 degrees, otherwise known as 330 degrees. And 0 plus 30 is 30 degrees, our normal 30 degrees. Sine of 30 we know is a half. Sine of 330 is negative a half. Because sine is negative in quadrant 4. The other middle for sine happens at 180. So if we do 180 minus 30 and 180 plus 30, we're talking about 150 and 210. Sine of 150 is a half. 30-degree reference angle in quadrant 2. 30 degrees off the middle for sine. And sine of 210 is negative 1/2. Because sine is negative in quadrant 4. Oops, in quadrant 3. think I said 2 earlier when I was referring to quadrant 3. Yikes. Any questions? We want to be able to use the graph to help us remember our values, to help us remember our quadrants. And there's a lot of pattern and structure that we can recognize. A lot of what we do in math is just recognizing pattern and structure, and then taking that pattern and structure and seeing where else it fits. Let's take a pause for 5 minutes and then come back and talk a little bit more about these graphs.